So today we're going to look into the properties of logarithms which allow us to manipulate logarithms a little bit easier. In this first property, you'll notice if I have the log base a of a product of two terms, that's equivalent to the sum of the first factor plus the sum of the second factor. And notice again the log's bases are the same. In the next property, I have a division of two terms, and that's equivalent to the log of the numerator minus the log of the denominator, keeping the log base the same again. Finally, I have the log of some base to a power, which is equivalent to that power multiplied by the log of that base. And we'll use these to do some problems. One of the types of problems we'll do is simplifying an expanded logarithm to a singular logarithm. So we notice right off that this is a sum of two logs, which equates to the log of the product of the two numbers, which is the log base 3 of 24. Do a couple more of those. Now in this case, if I were to see this as a subtraction and bring the 5 down first and then bring the 3 up, the power of 3 would be both to the 4 and the 5, which isn't necessarily the case. It's just to the first guy. So what I'm going to do is I'm going to say that's the log base 7 of 4 cubed minus log base 7 of 5, and thus the log base 7 of 4 cubed over 5, or the log base 7 of 64/5. So this problem has a little more going on with it. We have 2 multiplied by all this stuff inside, which we're going to want to simplify first using our properties. So this is 2. Notice I have multiples, so those will go up to powers. And this is the natural log of x minus the natural log of y squared minus the natural log of z cubed. Now for every subtraction that I see, I'm going to divide. Usually people have a tough time with this because they try to do too much at once. I'm just going to do this. I'll take the natural log of x over y squared minus the natural log of z cubed. And notice when we subtract, or when we divide this time, I'm not going to put another division sign down because dividing is the same as multiplying by the reciprocal. So that's the natural log of x over y squared, and when I multiply by 1 over z cubed, that goes in the denominator. And then finally, I'm going to take and bring this multiple up to the numerator, so this is the natural log of x squared, y to the 4th, and z to the 6th. Now they're going to want us to expand the logarithm using a combination of the log rules, so I'm going to break this apart as far as it'll go. This is a product, so I'm going to break that apart first into our addition. So this is the log of m to the 6th plus the log of w. Remember the base is 10 in this case. And then I have one more property I can use and pull the 6 out front, log of m plus the log of w. Similar problem, although what I think I'm going to do first, since this whole term is the 4th root, this is the same as the log of m to the 5th and cubed, all raised to the 1/4 power. I'll bring the power out in front, and that's the log of m to the 5th and cubed. But then within the parentheses, I've got a product, so I will break that apart into a sum and difference. M to the 5th and plus, and whoops, sorry, log, it's terrible, log of n cubed. And then I notice I have one more thing I can do. I can bring these powers out in front. So this is 1/4 times 5 log m plus 3 log n. And even cleaning it up a little more, distribute through 5/4 log m plus 3/4 log n. Same thing here. This is separated by a division first, and then we have the root on this, which we'll take care of in that order. So this is the log of x minus the log of, I'll just do this all in one shot, 1 minus x to the 1/2 power, so that power needs to go out in front. And this is actually the answer right here. Some people try to do too much and don't write this down, but they try to distribute a logarithm to these two terms. A log is not a number, so it can't be distributed. So don't do more than you need to do. All right, so let's get rid of those so there's no confusion. Now this is a little bit different. It's phrased different, but we're actually still doing the same things. You're going to be given two quantities of C and D. And they're going to tell you that the log base 3 of 10 is equivalent to C and the log base 3 of 5 is equivalent to D. So I need to write this logarithm, log base 3 of 50, in terms of C's and D's. And I notice that 50 is a product of 5 and 10. So since it's a product of 5 and 10, I can split it apart into the log base 3 of 10 plus the log base 3 of 5. Log base 3 of 10 I know is C, log base 3 of 5 is D, and that's expressed in terms of C and D. Same given, but now we have to find the log base 3 of 20. 4 and 5 is 20, but that's going to be tough here getting, there's my 5, but I don't have a 4. And 2 and 10 is 20, and there's my 10 again, but I don't know how I'm going to get a 2. But now I look at this and say, okay, well, wait, here's a 10, and that's a 5, and if I were to divide those, that's 2. So let's take a look and rewrite this. This is the log base 3. Again, we said this is 10 and 2 of 10 times 10 over 5. All right, and you could rewrite that if you want. This might even be a little bit easier. Log base 3 of 100 over 5. So that's a subtraction. It's the log base 3 of 100 minus the log base 3 of 5, which is the log base 3 of 10 squared minus the log base 3 of 5, which is equivalent to 2 log base 3 of 10 minus the log base 3 of 5. And hey, here you go. 2 log base 3 of 10 is C minus D. And our last example for the day, we would need the log base 3 of 270. That's the log base 3 of 27 plus log base 3 of 10. Now, I don't know how I'm going to get 27 out of 10 or 5, and I'm not. But I look at this and say, hey, wait a minute. What power of 3 is 27? Well, this whole thing just simplifies to a 3. And the log base 3 of 10 is just C, so that's how that simplifies. All right, quick and easy today. We'll see you next time.